to see the reaction of phenols. Reactions of phenols. Phenol. In benzene ring we are going to see the reaction. And there are two different, that is in OH also. So first we are going to see the electrophilic aromatic substitution. Electrophilic aromatic substitution. Electrophilic, we already discussed, that is electro. The electron carries negative sign. Philic, attraction. So if it has a tendency to attract the negative sign means it must carry which sign? Plus sign. Carries which sign? Plus sign. So first reaction is electrophilic aromatic substitution. Electrophilic means attract the negative sign. That means it carries positive sign. So now reaction on aromatic ring is called electrophilic substitution reaction. Phenol. What is the structure for phenol? We have one benzene ring. In that OH group is attached. Now we are going to see the reaction which takes place in the benzene ring. So that is called as a electrophilic aromatic substitution reaction. Reactions on aromatic ring. And while studying about the reaction on the aromatic ring, first we must find which group is directly attached to the benzene ring. Which group is directly attached to the benzene ring. Here it is OH. OH group is directly attached to the benzene ring, no? So the OH group on the benzene ring, whether it has a tendency to activates the benzene ring or deactivates the benzene ring. Here the OH group carries the lone pair of electrons, no? So it has a tendency to donate the electron. OH has a tendency to donate the electron to benzene ring. So it has a tendency to activates. If any group attached to the benzene ring donate electron to the benzene ring means then it activates the benzene ring. That is, commonly it is called as electron releasing group. Electron releasing group means activates the benzene ring. If it activates the benzene ring means it is always ortho and para directing. That means while studying about the electrophilic aromatic substitution reaction, first we might find the which group is attached to the benzene ring. Whether it has a tendency to donate the electron to benzene ring means activates the benzene ring. Activates means the electrophile goes to which position? Ortho and para position. So first we are going to see the nitration. Nitration, the name itself explains us what is nitration. What is nitration? Addition of NO2 group, bond NO2 group. Nitration is nothing but addition of bond NO2 group. Nitro, it is called nitro. Nitration means addition of nitro. And here, what is the electrophile? What is the electrophile here in the nitration? It is nothing but NO2 plus. It is called nitronium ion. It is called nitronium ion. This is the electrophile. So in nitration, which group added to the benzene ring? NO2. First, nitration means which is the electrophile here? NO2 plus. It is called as nitronium ion. It is called as nitronium ion. There are two types of reaction we are going to see here. First with the dilute nitric acid. Dilute, that means its action is very less. So dilute nitric acid and the temperature should be maintained at 298 Kelvin. So phenol, 298 Kelvin with the dilute nitric acid. It is already which directing? It activates the benzene ring, no? So it is ortho and para directing. It is activates the benzene ring, so it is ortho and para directing. So ortho position, ortho means 1, 2, 3, 4, 5, 6. 1, 2 position is called ortho. So O. Ortho position, which group is attached here? NO2. So ortho nitro. If we didn't have NO2 group means what is this called? Phenol. So it is ortho nitro phenol. And it is also para product, no? So 1, 2, 3, 4. 1, 4 position is called para. In 4th position, NO2 group is attached. So it is called para. NO2 there, no? So nitro. If it is no any substituent means a parent compound is called phenol. So para nitrophenol. So nitration means addition of NO2 group. What is the electrophile here? NO2 plus, which is called as nitronium ion. With dilute nitric acid, phenol, 298 Kelvin, two different types of products are there. That is orthonitrophenol and another one is paranitrophenol. Orthonitrophenol and another one is paranitrophenol. So now ortho-para directing we already studied, and we get two different types of products. One is ortho and para product. Get as a mixture, no? Now this ortho and para isomers are separated by, how will you separate these two isomers? We get ortho nitrophenol and also para nitrophenol. How will you separate this? By using a steam distillation. By using a steam distillation. First, orthonitrophenol. It is steam volatile due to intramolecular hydrogen bonding. That means easily volatile. Easily volatile. Due to intra means between. Intra means within the same molecule, one molecule. Paranitrophenol is less volatile. That means it not easily vaporized. Volatile. What is volatile? Easily vaporized. Easily vaporized is called volatile. Easily vaporized due to intramolecular. Intra means within one molecule. Paranitrophenol is less volatile due to intermolecular, between hydrogen bonding. That means which causes the association, between, association. Inter means associated with each other. Now this is the structure of ortho and paranitrophenol. Consider this is a orthonitrophenol. Yes, this is 1 and this is 2. Ortho position we have OH and NO2, no? So NO2 written like this. Orthonitrophenol. This is OH and here NO2. There is a force of attraction between oxygen, highly electronegative oxygen, and electropositive that is hydrogen. Electropositive hydrogen. So now electropositive hydrogen. That means what happens? Electropositive hydrogen and electronegative oxygen, both these has a tendency to attract each other. This is called intramolecular hydrogen bonding. Intra, within the molecule, we have a hydrogen bonding, no? So it is intramolecular hydrogen bonding. That means within one molecule. Paranitrophenol. Para, that means it must have a 1,4 position. This is 1, 2, 3, 4. 1, 2, 3, 4. That means between two molecules. Nitro group of one orthonitrophenol and hydroxyl group of another. So both these have a tendency to attract each other, and this type of hydrogen bonding is called inter. Inter means between two molecules. Inter means between two molecules. So these two molecules is called intermolecular hydrogen bonding between two molecules. So now we are going to see the reaction with concentrated nitric acid. Concentrated nitric acid. Phenol with concentrated nitric acid gives picric acid. Picric acid is also called as 2,4,6 trinitrophenol. It is also called as 2,4,6 trinitrophenol. 2,4,6 trinitrophenol. So picric acid is called as 2,4,6 trinitrophenol. So take phenol. Concentrated nitric acid. This is called as a nitrating mixture. This is called as a nitrating mixture. If any nitration takes place means we must have a nitrating mixture. What is a nitrating mixture? Concentrated nitric acid and concentrated sulfuric acid. We get 1, 2, 3, 4, 5, 6. 2, 4, 6. In this position, what is attached here? Nitro. So 2, 4, 6. Trinitro. Why tri? 3 NO2 group is there, no? So trinitro In 3 anode groups are there in the phenol. So it is called 2,4,6 trinitrophenol. Commonly it is called as a picric acid. So phenol with concentrated nitric acid and concentrated sulfuric acid, which is called as a nitrating mixture, gives a picric acid. What is picric acid? 2,4,6 trinitrophenol. 2,4,6 trinitrophenol. This is called as a picric acid, that is nitration of phenol, and the next one is halogenation. Name itself we can understand, addition of halogen. Now halogenation takes place in two medium. Bromination, consider bromination, addition of halogen, whether it may be chlorine, bromine or iodine. Now we are going to add the bromine. So bromine in non-polar solvents. Non-polar solvent means it not dissolve in water. It is not ionizes to give the plus or minus. So chloroform and CS2. What is this? Carbon disulfide. Bromine in chloroform or bromine in carbon disulfide. Temperature should be at low temperature. What may be the product? Monobromophenols. Like that. Orthonitro, paranitro, no? So that type of reaction is obtained in the non-polar solvent. If the bromine is dissolved in non-polar solvent, we get ortho and para product. This is phenol. Bromine in carbon disulfide. Temperature 273 Kelvin. We get two types of products. Ortho, 1, 2 position, ortho, 1, 2, 3, 4 position. So it is para. In ortho position, which one is attached here? Bromo. So it is called orthobromo. In which compound? Phenol. So it is orthobromophenol. And the next is para. It is ortho-para directing. This OH group is ortho-para directing, no? We get ortho product 1 and another one is para product. Para means which position? 1, 4 position. In the fourth position we have a bromo. In which compound? Phenol. We get two different types. And which is obtained in the maximum amount means major product is para. Due to the steric hindrance. So here it is steric hindrance, no? Near to each other. There may be some repulsion, but here it is opposite to each other. So it is more stable. So this is a major product. Para product is always a major product due to the absence of steric hindrance. Now, if the normal halogenation takes place in the presence of Lewis's, normal halogenation means without OH group. Consider. It should take place in the presence of Lewis acid like ferric chloride, ferric bromide. Bromination means ferric bromide. Chlorination means ferric chloride. If you want to add the chlorine means you have to take a Lewis acid as ferric chloride. Bromine means ferric bromide. Why you have to take that? Due to the polarization of bromine molecule. To polarizes the bromine. Then only it is cleaved as Br plus and Br minus now. So we need one Lewis acid. Then why don't you take in phenol? With phenol we didn't take any Lewis acid, no. Only bromine in carbon disulfide. Why don't we take this type of Lewis acid like ferric chloride or ferric bromide? But in phenol, polarization of bromine takes place in the absence of Lewis acid itself due to high activating OH group. This polarization can be takes place by the activating OH group in the benzene ring. So this is one of the reaction question, reasoning question. Why don't we take the Lewis acid in the bromination or halogenation of phenol? Due to the highly activating OH group in the benzene ring. Now in non-polar solvent it gives a mixture of ortho and para product, no. In polar solvent, that means it has a tendency to cleave to give H plus OH minus, that is water. Now bromine in water. Phenol, bromine in water. What happens? 3 Br. 3 H is there, no? 6 H is there. We need this position only. So 3 hydrogen, 3 bromine as leaved as 3 HBr. Totally 6 Br, no? 3 goes out. Remaining 3 goes and form a bond in that position where the hydrogen is placed. So bromination. It is 2,4,6 tribromophenol. 2,4,6 tribromophenol. 2,4,6. Which is attached here? Bromo. How many bromo? 3. So tri. In which compound? Phenol. It forms a white precipitate. That means it has a tendency to decolorizes the bromine water. Phenol has a tendency to decolorize the bromine water. So that only we get a white precipitate of 2,4,6 tribromophenol. 2,4,6 tribromophenol. And the next is important name reaction. Important name reaction. Name reaction is very, very important. So where there is a name reaction, you have to study that. So first one is Kolb's reaction. Kolb's reaction means phenoxide ion is generated by first phenol react with NaOH to give phenoxide. Since this is more reactive than phenol, so first it forms a phenoxide, then undergoes electrophilic substitution reaction. So now first we have to take a phenol with NaOH to form a phenoxide, and then the electrophilic substitution takes place. Why? Because phenoxide ion is more reactive than phenol. Phenoxide ion is more reactive than phenol. Here, what is the electrophile we are going to take? Carbon dioxide. What is the electrophile we are going to take? Carbon dioxide. Then what may be the product? Orthohydroxybenzoic acid. Orthohydroxybenzoic acid. Let's see the reaction. We have to take the phenol with NaOH. First it forms a phenoxide. What happens? H2O goes out. Instead of hydrogen, we have to take the Na. So this is sodium phenoxide. In the presence of carbon dioxide, which is an electrophile, with acidification. Carbon dioxide with acidification. First it forms a sodium salicylate. Here Na is formed first. And then on acidification, this Na goes out and we get a H here. So we get 2 hydroxy. Here it is 2, here it is ortho. Why it is ortho? 1, 2 position is called ortho, no? So it is 1, 2. Hydroxy benzoic acid. Both are same. We may say either ortho or 2. Both represents the second position. Hydroxy benzoic acid. This ortho hydroxy benzoic acid is called as a salicylic acid. If we have only OH on the benzene ring means called phenol. Only COOH means benzoic acid. Both are present in the same compound means it is called as a salicylic acid. Both are present in the same compound means in ortho position it is called as a salicylic acid. No need to mention ortho. Salicylic acid name itself mentioned that both are present in the ortho position. And the next is also a name reaction which is called as Reamer-Teamer reaction. Here we are going to see the reaction of phenol with chloroform and NaOH. Here we are going to get the aldehyde. Kolb's reaction we get acid, no? Here it is aldehyde. First we get one intermediate called substituted benzol. Benzol. What is benzol? C6H5 with 2. This is called benzol. CH bond is called benzol. And further on acid, there we have acid hydrolysis, no? Here acid hydrolysis takes place. Here it is alkali hydrolysis. Here it is alkali hydrolysis takes place to give salicyl aldehyde. To give salicyl aldehyde. First phenol react with chloroform and aqueous NaOH. Chloroform and aqueous NaOH. Same process. Alkali means it has a tendency to form Na here. Chloroform CHCl2. CHCl2. Here one H is there, no? Replace that. So CHCl2. This is called benzol. This group is called as benzol. CHClCl. Then with NaOH, what happens? Sodium salicyl. This is called sodium phenoxide. With aldehyde group, one intermediate is formed. Which on further hydrolysis? H plus HCl. That means HCl is there. NaCl goes out and we get OH. Salicyl aldehyde. Salicyl aldehyde. If you have OH and COOH means it is called salicylic acid. Here we have aldehyde. So it is called salicyl aldehyde. Salicyl aldehyde. So Kolb's reaction, salicylaldehyde or salicylic acid. In Kolb's reaction we prepare salicylic acid. But in Riemann-Timmer reaction we prepare that is salicylaldehyde. Salicylaldehyde. Now we are going to see the reaction of phenol with zinc dust. Reaction of phenol with zinc dust. It is an important 1 mark also. That is phenol with the zinc dust on heating. What happens? Z and O goes out. Phenol with the zinc. Z and O goes out and we get benzene. The removal of zinc oxide. So phenol with the zinc on heating is there, no? So on heating, what happens? Z and O goes out and we get benzene. And the next process is oxidation. We know oxidation means addition of oxygen. Oxidation means addition of oxygen. So phenol with chromic acid. Phenol with chromic acid. Chromic acid or chromyl chloride or anything strong oxidizing agent. That means how this reaction takes place. Consider like this. That is, write the phenol in this manner. H plus goes out. Oxidation, no? So removal of hydrogen. Here also we have one hydrogen, para position. This bond shift here. So it becomes double bond. This carbon is already satisfied with 4 valency. So if a bond, new bond is bond means it has to shift one bond to next carbon. So this bond comes here and this bond comes here. It becomes double bond. Oh. So this bond comes here. Now this is already satisfied with 4 valency. So it has to lose one bond here. What happens here? H plus goes out. Addition of oxygen. So this oxygen comes here. 2 oxygen you have to take. 1 oxygen comes here and another oxygen goes out with the water, H2O. So how the reaction takes place? First H plus goes out. The bond shift here. This is already satisfied with 4 valency. So it has to leave one bond to next side. Now new bond is formed means it has to shift the another bond now. So it comes here. What happens? This H plus goes out with 1 oxygen as H2O. And another oxygen comes a bond here. So O, double bond, here single bond, here double bond, single bond, double bond O. This is nothing but benzophenone. This is nothing but benzophenone or benzoquinone. Quinone, commonly it is quinone. Benzoquinone. So phenol on oxidation gives benzoquinone. Benzoquinone. On. Ketone is there, no? So quinone. Now we are going to see the commercially important alcohols. Commercially important alcohols. Commercially important alcohol. First one is, consider methanol. First one is methanol. Methanol, we know. What is the formula? CH3OH. It is also called as wood spirit. That means it is obtained by the destructive distillation of wood. That means destructive distillation of wood. That is wood on destructive distillation. We get a methanol. So it is called as a wood spirit. So it is called as a wood spirit. And now chemically it is prepared by catalytic hydrogenation. Hydrogenation means addition of hydrogen. Catalyst, in the presence of catalyst of CO at high pressure and temperature and the presence of ZnO Cr2O3. This is a catalytic hydrogenation. No? So here this is a catalyst. So carbon monoxide on hydrogenation in the presence of catalyst. What is that? Carbon monoxide with the hydrogen in the presence of catalyst. Temperature should be maintained and pressure should be maintained. Pressure is maintained at 200 to 300 atmosphere. Temperature 573 to 673 Kelvin. We get methanol. So carbon monoxide undergoes hydrogenation in the presence of catalyst at a pressure 200 to 300 atmosphere. Temperature 573 to 673 Kelvin. We get 4 hydrogen, no? 3 hydrogen in this form and 1 hydrogen, here 1 oxygen. So we get methanol. So we get methanol. So next we are going to see the properties of methanol. Properties of methanol. Properties. Physical properties first. What is its appearance? It is a Colorless liquid. Properties. First methanol is a colorless liquid. What happens? It boils at 333 Kelvin. These are the physical properties. And it is highly poisonous in nature. Highly poisonous in nature. So it is a colorless, boils at 337 Kelvin. Highly poisonous in nature. Ingestion. Ingestion means if it taken in. Ingestion of even in small quantities of methanol leads to blindness. Small quantities means blindness. Large quantities means it even causes death. So, poisonous. Highly poisonous. Ingestion, if we take inside or drink, that is, if small quantities mean it causes the blindness. If it is taken in the large quantities, what happens? It causes the death. So it is also used as a solvent. Solvent, so it is used to dissolve something. So solvent in paint, varnishes, and chiefly for making, what is this? Formaldehyde. For making formaldehyde. Methanol on oxidation gives formaldehyde, no? So chiefly for making formaldehyde. It is used as a solvent in paint, varnishes, and chiefly for making formaldehyde. Now we are going to see the next commercial uses of alcohol is ethanol. How it is prepared? It is prepared in molasses. In lower classes we studied. By fermentation process we prepare the ethanol, no? So, sugar in molasses. That means the waste obtained from the sugarcane. The sugarcane or fruits such as grapes. So, molasses from sugarcane or some substances obtained from fruits like grapes converted into, first it is converted to glucose and fructose. What is the formula for glucose and fructose? Both have the formula C6H12O6. Then how it differs with each other? Glucose means it contains the aldehyde group. Fructose means contains the keto group. Same formula but different functional group is there in the presence of an enzyme invertase. So first using the invertase as an enzyme, this molasses converted to glucose and fructose. And the second step, this glucose and fructose undergoes fermentation by using an enzyme called zymase. So now how this reaction takes place? How this reaction takes place? That is molasses, sucrose, disaccharide. Sucrose is a disaccharide. We already studied, no? So, disaccharide. So, formula is C12H22O11 with water molecules. What happens? Enzyme invertase convert the important one more. Enzyme invertase convert the sucrose to glucose and fructose. Glucose and fructose. Now, the glucose convert the into ethyl alcohol by using zymase. Glucose convert to ethyl alcohol by using zymase. This has a tendency to form a ethyl alcohol with the removal of carbon dioxide. With the removal of carbon dioxide. So, this is ethanol. First from molasses by fermentation process it is converted to glucose and fructose by using an enzyme called invertase. How this glucose and fructose are differentiated? Glucose have a aldehyde group and fructose have a keto group. And this glucose and fructose further undergoes the decomposition with the zymase fermentation. How this fermentation takes place? Converted to ethyl alcohol. Glucose and fructose is converted to ethyl alcohol with the removal of carbon dioxide. With the removal of carbon dioxide. Now, in what are the applications? That is, it is used in wine making. Ethanol is used in making wines. That is, grapes are the source of sugars and yeast. Mainly it is obtained from grapes, no? Also obtained from, so when the grapes get ripened, what happens? The quantity of sugar increases. The quantity of the sugar increases and the yeast grows in the outer screen. So, that is, grapes ripen means sugar concentration increases and on the outer skin what happens? Yeast grows. That means on the outer skin what happens? Yeast grows. That means when the grapes gets crushed, what happens? Sugar and the enzyme comes in contact. Sugar and the enzyme comes in contact and the fermentation starts. So first we have to take the grapes. It contains it is the sources of sugar and yeast. When the grapes ripen, what happens? The quantity of the sugar increases and the yeast grows on the outer skin. Now we are going to crush that. Now what happens? Both the sugar and the enzyme comes in contact with each other. Now what happens? Fermentation starts. When the fermentation takes place in anaerobic, what is that anaerobic? It is in the absence of air. Fermentation starts. This fermentation takes place in the absence of air in a closed condition. What is the process obtained here? During this process, carbon dioxide is released. Fermentations mean carbon dioxide is released, that we discussed in the preparation of ethyl alcohol by using cymase. In the presence of ethyl alcohol by using cymase. Similarly, here also carbon dioxide is released during the fermentation process. What is the action of enzyme? It is action of enzyme is inhibited once the percentage of alcohol exceeds 14%. Once the alcohol is formed, the cymase activity gets decreased. When the alcohol reaches the 14%, the action of the cymase decreases. Action of the cymase decreases. The fermentation takes place in which process? Anaerobic condition. That means in the absence of air. If air gets into fermentation means what happens? The oxygen of the air oxidizes the ethanol to ethanoic acid. We need ethanol. But if there is an oxygen means what happens? Primary alcohol and oxidize to give acid. Ethanol and oxidation gives ethanoic acid. Now which destroys, when ethanoic acid is formed, it destroys the taste of the alcoholic drinks. So first we are going to see the physical properties. It is a colorless liquid, and it boils at 351 Kelvin. Boils at 351 Kelvin. It is used as a solvent in the paint industry and also used in the preparation of number of carbon compounds. That means ethyl alcohol. So commercial alcohol. Ethyl alcohol is also a commercial alcohol. It is unfit for drinking. When it is mixed with copper sulfate and pyridine. Why it is mixed with copper sulfate? To give a color. Why it is mixed with pyridine? For a foul smelling liquid. It is called as denaturation of alcohol. Copper sulfate and pyridine makes it a denatured. That means it loses their originality. So denaturation of alcohol. When what is called denature of alcohol? When ethyl alcohol mixed with copper sulfate and pyridine. This is called denaturation of alcohol. These are the properties of phenols.